computer.
Thank you.
And now I'd like to turn it over to Don Booth to give background on the series and to introduce Tim Weber. Thank you, Don.
Thanks, Kathy. So buildings are the largest source of greenhouse gas in Toronto. Our committee discovered that if Toronto tries to heat and cool its 400,000 plus buildings with air source heat pumps, that we will need to generate much more electricity than we do now. We also need to expand the grid to carry all that electricity. Research by the Boltzmann Institute and by the Independent Electricity System Operator of Ontario predict an enormous demand at enormous cost. By contrast, geothermal and district energy use very little electricity. The more geothermal we use, the less energy we need to generate, and the fewer demands we place on the grid. TEAC is mounting this series of speakers because we want to learn more about geothermal and more about district energy. We want to see if we can use what we learn to make geothermal and district energy a more popular way to heat and cool buildings. We're beginning with geothermal. This is what led us to invite Tim Weber to speak with us today. We'd like to thank Tim. He's the co-founder of Diverso Energy for agreeing to speak with us about his business, the current state of geothermal, and prospects for the future. Tim has been working in the HVAC industry for over 25 years and in geothermal for 15. Diverso is one of the leading developers, owners, and operators of geothermal energy systems in Canada. Diverso's ground source energy systems typically reduce the carbon intensity of a building by 80%. The company's clients are among the leading developers in Southern Ontario. Their systems heat and cool buildings from condos to office towers, malls, and everything in between. Tim leads the company's business development efforts, where he works with new clients and identifies new market opportunities. In a moment, I'll turn you over to Tim, but first, let's watch a short Diverso video called How Geothermal Really Works. Kyle, I'll let you press play.
Way. Carbon. The electrification of buildings has become a priority for many cities, and geothermal offers one of the most attractive options for developers. Although not a new technology, there are a lot of misconceptions about how geothermal really works. Whether a building is 4 floors or 40 floors, a geothermal heating and cooling system operates the same way. In each case, a traditional geothermal system is made up of 3 things: the ground, pipe, and water. To better understand how geothermal works, first, let's look at the heating and cooling system of a typical building. Most multi-residential buildings have a central water loop which circulates throughout the building. This water loop is connected to heating and cooling equipment such as heat pumps. In the summer, heat pumps cool the suites and move the heat into the central water loop. From there, it is pumped to a cooling tower on the roof where it is rejected into the air. In the winter, the process is reversed, and the heat pumps warm the suites using the heat from the central water loop. To maintain a constant temperature, heat is injected into the loop by a boiler plant. The heating and cooling process in a geothermal building looks almost identical. In the summer, rather than using a cooling tower to discharge the building's heat into the air, the heat from the building is stored in the ground, turning the geothermal bore field into a large thermal battery. During the winter season, the building takes advantage of the stored energy collected over the summer to heat the building's central water loop, just like a boiler would. As you can see, when making the switch to geothermal, your building's heating and cooling distribution system remains unchanged. Both the conventional and the geothermal buildings are largely designed, constructed, and maintained in the same way. The most obvious difference with the geothermal building is the absence of a boiler and a cooling tower. For developers, this means freeing up space for rooftop amenities or additional residential space. To simplify geothermal even further, Diverso Energy offers several solutions, including a full utility model where they design, build, own, and operate the geothermal bore field. This geothermal solution allows developers to maximize the value of their project while staying focused on what they do best.
Thanks, Kyle. And now I'd like to turn it over to Tim. Feel free to type your questions in the chat. Tim?
All right, thank you, everyone. Just gonna pull up this presentation. All right, can you see the PowerPoint okay?
Yep.
Yep, great. Yeah, again, thanks for that warm welcome and introduction, and thank you everyone for taking this time out of your evening. I will say I'm quite surprised to have this many people show up at 7:30 on a weekday to see hear someone like me talk about geothermal. It's surprising and amazing at the same time. So thank you, everyone. So my objective tonight is to keep this relatively high level. This isn't meant to be an in-depth technical presentation. I just want to kind of walk through what is geothermal, what are some of the objectives or kind of polarizing objectives that we're seeing. There's kind of a dichotomy in the industry right now between profitability and sustainability. What are the misconceptions? There's no shortage of those out there. Geothermal's been around a long time. The technology and the applications have evolved, but not everyone's perspective of it has evolved. And what are some of the market-ready solutions and what will drive change? And probably more so, what is driving change? So first misconception, geothermal equals heat pumps. And the reason I bring this up is I hear this a lot from mechanical engineers, contractors. They assume that if a building is utilizing geothermal, the building has to be heat pumps. And that's actually not true. We're doing a lot of projects that have water source VRF. We've got projects with chilled beam, DOAS systems in office buildings, fan coils. Basically, any heating and cooling system on the market today can be integrated seamlessly with geothermal. And the reason why that's significant is what we're trying to do is make geothermal this, kind of seamless, half degree least resistance, low carbon option for developers. And developers, like most people, don't like change. So the more we can keep the building or keep that status quo as is, the more friendly the technology is and less resistance. Another misconception is geothermal requires space. And I think this is probably less of a misconception in Toronto because we've been doing geothermal in high-rise buildings for a long time. But if you go south of the border, almost anywhere in the US, the idea of putting geothermal in a downtown 40-story building is unheard of. And I think historically, geothermal was primarily put into schools, universities, residential homes, but there was football fields, or there was parking lots, or large amounts of space. And there's a bit of a misconception that if you're putting geothermal in a large building, you need large space. Therefore, high density solutions are not an option. And that could be not further from the truth, or nothing could be further from the truth. And a lot of that is what's been happening here in Ontario. For those of us that have been in this industry for a while, we've kind of adopted this process, not so much a technology or a new technology, but a process where we come in first before these buildings are constructed. We'll drill our holes, could be 80, 100, up to 180 holes, about 600 to 800 feet deep, and we drill the holes from the surface. So we're first on site, nothing's happened yet. We drill all of our holes, and those holes are cut and terminated below the final grade. So if there's 3, 4, 5, 6 levels of underground parking, like this project here in Mississauga, that's a 65-story building with 6 levels of underground. That was a parking lot before we arrived. We drilled, I think it's about 180 holes on that site. We capped all the holes and plugged them with a tool that went down inside the pipe. We cut the pipe. We moved off site. They spent about a year shoring and excavating down to the bottom level of this pit. They poured their footings. We came back in, collected all of our pipes, tied them together. So basically our entire geothermal bore field is underneath the footprint of this building. And most projects in Toronto are zero lot line. So the only space you really have is underneath the building footprint. And that's become the norm for us, or the industry in Ontario, Southern Ontario. This is another example. This one is, so this project here is a record. It's a 65-story building. As far as I know, it's the tallest 100% geothermal building in North America, possibly the world. I haven't really looked that far, but certainly in North America. This is another new one. We just finished the tie-in on this project. It's in Mississauga. It's called the Alba Condos, and it's 8 levels of underground parking. So that was a new one for us. So we had to cut our pipes from surface 8 levels down, so almost 100 feet down. We had to cut the pipes, pull them out. So that's essentially 100 feet of drilling that does not get utilized for anything, but that's a lot easier than trying to crane drill rigs down into this pit and drill from that level. So again, this really is all about making this as seamless for developers, the least amount of impact on their schedule and their critical path. So the lion's share of our work is completed before the developers even start the projects. This is what it looks like down below. Our holes are about 15 to 18 feet apart, and they're collected with these 3-inch lines where they're all brought back to one central location where there's a manifold. And this is what that looks like. So all of these pipes are collected in one spot. So this manifold right here and these pumps basically replace a cooling tower on the roof and a heating boiler. So this is now kind of the energy system of a geothermal multi-residential building. It's, not much to look at, pretty simple, but that's kind of the point. It's meant to simplify the system. So now the condo corporation or the building owner have less equipment to maintain, less equipment they have to worry about replacing in the future and carrying a capital reserve for replacement, less maintenance, less repairs, less failures, less chance of the system not functioning or not having heating and cooling because they've removed mechanical equipment and replaced it with incredibly simple and resilient high density polyethylene pipe buried in the ground. So this is kind of what a typical rooftop looks like of a conventional building. This is a project we did in Kitchener, and I only show this. It's just, there's the environmental side of geothermal. Yes, we're eliminating natural gas, eliminating that cooling tower, significant carbon reduction. But for the residents, getting equipment off the roof, opens up all kinds of opportunities for the architect. And obviously, it doesn't always make sense to put a pool on the roof, but that's an option that would not have been there if there was a loud mechanical room or a cooling tower right next to that pool. That would not have been a viable option. Another misconception, drilling, the technology cannot scale due to lack of drilling resources. And, we've been hearing this forever, and I'm not going to say there isn't truth to this, but the industry as a whole is working hard to get out in front of this. We at Diverso have some of our own rigs, and we have 6 more on order that should be in sometime next summer because it's a pretty long delivery period for drill rigs. So we're trying our best to get out in front of that. In the meantime, we're also bringing oil and gas drillers and oil and gas rigs from Alberta, which, I have to say the irony of that is certainly not lost on me. We've got oil and gas drillers who've been doing that their entire lives now working in Ontario drilling for geothermal. And it's kind of the perfect example of reallocating resources and skills or retraining. This is a driller who's still drilling. They're doing the same thing, making the same amount of money. The only difference is they're living out of a hotel in Mississauga rather than a camp up in Fort McMurray. And instead of being -30, it's -5. But instead of drilling for oil, they're drilling for geothermal. And they don't really care. And it's great because there's a lot of talented drillers and a lot of great equipment out in the oil patch or out west that we're just reallocating in Ontario. So between that and acquiring our own rigs, that's kind of how we're trying to get out ahead of this sort of massive buildup we're going to see, or scaling we're going to see over the next couple of years. So polarizing objectives. And, if there's any developers on call tonight, they'll certainly understand this, especially in 2023. This week, I've been at the building show in Toronto, which is an annual conference at the convention center where most of the developers in Toronto get together, go to sessions, learn a few things, but it's really them the end of the year celebrations, or in some cases, end of the year crying in their beers. And I think this year there's going to be a lot more crying and celebrating. It's been a tough year for developers. Construction costs have increased significantly. Interest rates have gone up on their loans as well as consumers, causing obviously a reduction in buyers. A lot of projects are sitting on hold. They're carrying land loans. It's just been a really difficult time for developers. But on top of that, now there's also a requirement to be low carbon. So it's kind of stacking one more thing on top of an already existing problem. And, we as an industry recognize that. And it's kind of our goal to, how do we, rather than adding more things to their plate, how do we take something off of their plate? And this has always been, polarizing objective in the industry, is competing sustainability versus profitability. Another issue that they have, rising construction costs, that's been an issue for a couple of years, but that coupled with, again, interest rates and reduced demand is also causing a lot of pressure and tension for developers. And again, not necessarily the right climate for innovation and trying new technologies. And it's not just the developers, it's the consultants, like developers, mechanical engineers, construction managers, contractors. The construction industry as a whole does not like change. And the more time I spend in it, I understand why. There's a tremendous amount of risk involved in development already. I can't think of another industry where 70% of your revenue is fixed and 100% of your costs are still variable. And those costs are impacted by market conditions, interest rates, supply chain issues, all kinds of things. So it's an industry that doesn't like change. Contractors don't like change. Mechanical engineers don't like change. They like copy, paste, repeat. And that's just the nature of our industry. But as we heard earlier, these are also the same buildings that have these buildings have the greatest contribution to climate change. They emit more emissions than anything else in the city. So that's, again, a bit of an issue. It's a problem we need to fix, but it's an industry that's not really looking to change. But, thanks to policies like the Toronto Green Standard and, soon to be the Ontario Building Code kind of moving in that same direction, aligning with municipal codes like the Toronto Green Standard, change is no longer an option. Status quo is no longer an option. And developers are starting to realize that. Some of them were more progressive and got out in front of it. Others would rather just keep their head in the sand until they have a gun to their head and they have to change. But regardless, not changing is no longer an option. So what it's forcing them to do is look at alternatives. What are the opportunities? What can I do that has the least amount of impact on my schedule, my budget, my ability to sell, my sale price, all of those things that are so sacred to a developer. They're looking at options to try to, maintain their pro forma while still aligning with these new, very aggressive standards. So kind of from day one, the mantra, I guess, of Diverso is, what if we treated geothermal just like any other utility? Nobody really talks about how much natural gas infrastructure costs. No one really cares. Nobody knows what's involved with that. All they know is when you build a building, you connect to Enbridge, and that's it. It's always been an unfair and unlevel playing field, because with geothermal, historically, it's a lifetime worth of energy you're expecting someone to pay for up front. You don't have a homeowner paying for the natural gas infrastructure and cutting a $30,000, $40,000 check. It's a monthly bill. Same with electricity, same with anything. So our approach was always, well, what if we turn geothermal into a utility and treated it the same way every other energy source is treated? By removing that upfront cost, removing the stress, we'll take responsibility for building it, just like Enbridge takes responsibility for the natural gas infrastructure. So we'll design it, we'll build it, we'll pay for it, we'll own it, we'll operate it, we'll make sure it performs, just like Enbridge makes sure that you always have the right amount of gas at your property. It's our responsibility to make sure there's the right amount of thermal energy coming into the building. If there isn't, we don't get paid. Just like Enbridge, you wouldn't pay your gas bill if there was no gas. So it's really just copying. It's nothing new. We're just copying what every other energy source has done for 50, 60 years. It's the same thing. And what ends up happening now for these developers is the building actually becomes either the same cost or slightly less because they no longer have to pay for cooling towers and boilers, but they still get a 70 to 80% carbon reduction. They also get none of the risk. Geothermal, as simple as it is, operating it is not necessarily all that easy. There's a lot of balancing that's required. Believe it or not, condos in Toronto are cooling dominant. So we actually see on all the projects that we're monitoring that there's more energy going into the ground in a year than there is coming out. So we have to manage that imbalance, and that's just part of the responsibility of owning a bore field. So we're shifting that responsibility from the building owner onto us as the geothermal utility, allowing them to do what they do, and that's operate the building, bricks and mortar, kind of more just traditional skill sets, traditional responsibilities. For the building owner or the condo corp, it's also a win. It helps the developer up front meet the green standards without impacting their budget and their sale price and impacting a go-to-market proposition. But for the occupants, and that's always been incredibly important for us, there's three stakeholders here. There's us, the developer, and the future occupants. And it's a bit of a fixed pie. One entity wins too much, someone else loses. So we're always trying to split that difference. And I think the big win for the condo corporation and the occupants is it's a hedge against future unknowns. And those unknowns could be, where's carbon tax going? As trades become more scarce, the cost to repair and maintain and the capital reserve required to replace cooling towers and boilers continues to escalate. Those costs all go away. So for the condo corporation, it really just simplifies their budgeting. It's cost guarantee and cost certainty. And there's not too many things in real estate where you have cost certainty for 30 years. They get the performance guarantee. Nothing else in their building has a performance guarantee for 30 years. If the elevator breaks in 10, that's on them. So that's just one thing in the building that they don't have to worry about paying for, fixing, replacing, repairing, or even thinking about for 30 years. The other thing it does is future-proofing. The City of Toronto has a mandate by 2040, all buildings are net zero. You can imagine the complexity, cost, and hassle of retrofitting a 300-unit building while the occupants of a geothermal condo and the condo corporation, again, one more thing they don't have to worry about. Their building is future-proofed. It's within striking distance of being net zero for not a lot of cost or hassle. That building can be basically completely eliminate any need for natural gas. So you can sever the natural gas connection on that building quite easily, as opposed to a conventional building where that would require a very costly and complex deep retrofit. So I mentioned earlier, choosing between sustainability, profitability, really the objective here is those are two things that are no longer mutually exclusive. It really, whether they like it or not, with our model and with geothermal, those two things go hand in hand. So sustainability and profitability is no longer a choice. So the question is, why change? And the reality is not all developers want to change. As much as we're trying to, make this easy, make it simple. Business is good right now, and business is good for a couple of reasons I'll get into. But when we started, we kind of thought we had a bit of a game changer. We've got the best Tylenol on the market, and everyone's going to want this. It's free geothermal. You can reduce your carbon footprint in the building for the rest of its life by 75%. It doesn't cost you anything. We'll take care of it. And we got almost no traction. I'd say 98 to 99% of the developers in the city wanted nothing to do with it. And at first I was frustrated by that. The more I've gotten to know developers, I now realize why. Even though it didn't cost anything, what I could not solve is the complexity, and there was no need. There was no need to change. It was a hassle. There wasn't enough reason for them to do it. And I think, fortunately for us, there were a few early adopters. And if you look at the, trying to remember what this is called, law of diffusion of innovation, I think it is, you have early adopters that they come along early. And thankfully for us, there were a few of those, just enough for us to keep the lights on for the first 6 or 7 years. And I'd say now we've kind of transitioned into that early majority stage. And the reason for that primarily is policy, but I think it's also momentum. any business historically, once you get over that threshold of momentum, everything starts to change. And what we're seeing now is developers are quite competitive, and they're looking at other developers. Like, oh, Camross did geothermal at the exchange. Now I want to do it over here. What's Minto doing? What's Aspen Ridge doing? And oh, if they're doing it, I should do it. The other thing that's shifted too is there's enough systems out there now that are operational. There's enough data, proof of concept. It's taken away some of the mystery. It's taken away some of the risk. There's enough data points now that developers know that, okay, this is a system, if done properly, actually works. So I think that's also helped. But for sure, the number one driver is policy. And that's where, I think of any incentive or policy I've ever seen, and I've been in the industry long enough to see success and failures attached to incentives and programs and policies. The Toronto Green Standard, I think what makes it so good is it by far has had the biggest impact on geothermal as a technology, but nowhere in the entire policy is the word geothermal mentioned, which I think is pretty cool. It's a completely technology agnostic policy. What it does instead, it doesn't tell the developers what to do. It tells them where they need to be. It tells them here's where your energy targets need to be, and here's where your carbon targets need to be, and here's what your envelope, your TEDI needs to look like. How you get there, we don't really care. So it doesn't provide necessarily a roadmap, it just provides an end result. And I like that because it's kind of the idea of the public sector creates the problem and the private sector will always create the solution. And what happened 9 years ago is we were walking around with a really great Tylenol, but we were too naive to realize that no one had a headache. Well, fast forward 8 years, now everyone has a headache and now they want the Tylenol. So fortunately for us, the market shifted. They're looking for a solution, and our objective is to be that path of least resistance of achieving these very aggressive carbon and policy standards that the City of Toronto has forced on developers. And as much as they may complain, and I think back to, I don't know, it was probably in the 1960s when the government decided every car must have a seatbelt. And the car manufacturers got together and they lobbied against that. And you're going to kill the automotive industry. Nobody's going to pay for seatbelts. And, what do you think you're doing? And they hired lobbyists, and it was a huge deal. Obviously, they lost. And it's interesting that something as simple as a seatbelt, the amount of lives that it's saved, those car manufacturers didn't want it. Fast forward 70, 50, 60 years, and safety, ironically, is the number one marketing tool for any car manufacturer. There's awards for it. That's the first thing that they brag about over horsepower, performance, or anything else, our safety rating. And I think we're seeing the same thing with developers. The same developers that slammed the door in our face 6 years ago are now trumpeting how innovative and how sustainable they are, which is totally fine. I think they're starting to realize, like, oh, this isn't so bad. I get the cachet of being green, and it doesn't really have a negative impact on my project. And I don't think that matters, because ultimately that was the whole purpose of this, is allowing developers to hit these aggressive targets without impacting how they do business. So I'm going to quickly go through just a couple of examples. This is a condo in Toronto, 420 units. And the reason I'm bringing these up, it kind of goes back to the beginning of the misconception of, can you do geothermal in large buildings? And can you do 100% of the heating and cooling in large buildings? And as much as it's not easy, and the design sometimes gets pretty tricky, and we've got to work with the right mechanical engineer, the more experience we get, the more we're able to push those boundaries on how tall we go with a smaller footprint. So these buildings are from a few years ago, a little bit less complex, but 6, 7 years ago, these were still considered pretty big buildings for geothermal. This one's 600 units, 26 stories, 2 towers. This is the one that had the 8 levels of underground parking, 32 stories. This one we're drilling next month. And this was a tough one. This is 101 Spadina, very tall building, very small footprint. We had to get extremely creative on some of these projects. We're using something called quad pipe, which has never really been done before in Ontario. We're putting 4 pipes in each hole, so we can get about 20% more capacity out of the footprint of the building, just so we can address those extra floors without having to put in a boiler to augment the geothermal. This is kind of a flagship project for us. This is the Exchange District in Mississauga. There'll be 3 towers here side by side, and they vary between 35 and 65. Actually, 2 of them, now I just heard the third one's going to be 70 stories. So 35, 65, and 70-story buildings, and they're a mix of rental and condos. So that's, I went through that pretty quickly. Wanted to keep it within the 30 minutes, but also wanted to leave a little bit of time if anyone has any questions. And as I mentioned, this wasn't meant to be a technical deep dive, but if you do have any technical questions, I'll do my best. I'm not an engineer, but I'm reasonably technical. So I'll stop there.
Thanks so much, Tim. That was fascinating and very inspiring. Rose, we noticed there's some questions in the chat, and please feel free if questions are coming to mind now. Please type them in the chat. And Rose, over to you to voice those questions to Tim.
Sure, great. So we've got a couple of questions. Dawn's question is, how do you handle the billing? And what about credit? And I guess utilities do that, but how does it work with geothermal with the billing?
Yeah, so the billing is pretty simple. We invoice the building monthly, but as far as credit, it's not so much the developer, because the developer builds the building and they hand it over to a condo corp, or even the case of a rental, they might stabilize it and sell it to a REIT. So no different than any other utility. It's really about the viability of the building itself. So this is a tower in Toronto. Will it be occupied? Will it require heating and cooling for the next 30 years? Will it be mothballed? And I think it's safe to say most of these projects, the answer to all of those things is no, it will. This is a good building. And, you know, like any other utility, if the building is in default, we do have the ability to limit access to the heating and cooling. That's obviously hitting the nuclear button, but no different than any other utility, we do have that leverage. And so far, we've had no issues with billing.
So I'm guessing that what Dawn was getting at is, how do you charge for heat?
Oh, I'm sorry. Yeah. So and that's the beauty of this. It's a flat fee. So our invoice is actually fixed for 30 years, because as much as geothermal is an energy source, and I'm comparing it to other utilities, it's not so much consumption based. This is really kind of a spreadsheet exercise based on our investment and our cost to operate and maintain the system, which we haven't experienced. That's really a fixed cost for us. Therefore, our invoicing is fixed. And that's what I was referring to in the slides about cost certainty for 30 years. We can show them a 30-year payment schedule, unlike any other consumable technology repair or any other energy source.
May I ask just for a bit of clarification? So you bill the building, the condo corporation or whoever owns the building, and
Correct.
Individual tenants pay them. And if somebody doesn't pay, that's the condo's problem.
Yeah, no different than any other common area element or common fee. So our fee could either be rolled into condo fees. In some cases, part of it's part of sub-metering.
So it doesn't matter if I crank up the heat in my place to make it hot and somebody else, how much energy I use, it doesn't matter.
It doesn't matter for geothermal. There is an incentive for you in a condo that's geothermal to not do that, because your heat pump will run more and your electricity bill will be higher. So there's some accountability there. But yeah, it does not impact the geothermal charge.
Thank you.
Thanks, Dawn. I'm going to do something similar. I'm going to read the question, but then with the follow-up, I'll ask people to unmute if they have a follow-up. So there's a question from Ken Jackson. Can you install geothermal in an existing building, for example, to replace a heating system that needs to be replaced? And the question that came up for me also is, when you talked about cost certainty for 30 years, what happens after 30 years? So those two might be related.
Sure. So first question, the answer is technically yes, but there's a lot of variables that sort of need to line up. Question, variable number one, does the building have a heating and cooling system that is compatible with geothermal? So kind of a water-based central plant type system. And then the bigger variable is, does it have a parking lot? Because obviously with an existing building, we've missed the opportunity to pre-drill under the building footprint. So retrofits are tricky. We're limited to buildings that have some type of either green space or surface parking lots. To answer your second question, the end of 30 years, basically the system reverts back to the building owner, and they can choose to pay us to manage it, pay someone else to manage it. They can do whatever they want with it. It's essentially theirs.
So I just have a follow-up, and I can't see Ken on the screen, and I'm not sure if he does as well. But I know of a situation where a building owner asked the city to use the adjacent laneway. Do you ever use public land? Has that ever come up?
No, I think the city, the same folks, the architects of the Toronto Green Standard have been working very hard with, other departments in the city to make revisions to their bylaws and allow geothermal to be used on, in city parks. So if you're building adjacent to a city park, that city park now can be allocated to drill holes and to heat, for geothermal to heat and cool the building. It's still dealing with the city. There's no doubt it would be, no shortage of brain damage involved in trying to get that done. There's also the consideration that that land is now encumbered for the life of that building. You can't do anything else with it. But if there's a kind of certainty that it's not going to be, reallocated to something else for a long period of time, that may be a viable option.
Okay, thanks. So we have a question from T. Anderson. Is auxiliary or oversizing the heat pump required for cold climates?
Yeah, that's a great question. And I think that's where that's probably coming from. With air source heat pumps, historically, that's always been the issue is, when the temperatures drop to -15 or -20, the efficiency and the capacity of the heat pump deteriorates significantly. One of the nice things about geothermal is the bore field really has no idea whether it's -30 or +30 outside. So we have a fairly constant temperature, and we can predict that. We know we're going to be around 50 degrees entering water temperature in the winter, which is kind of the sweet spot for a water source heat pump. And we're not going to be any more than 80 degrees in the summer, which is also kind of the sweet spot for cooling for a heat pump. So if anything, there may be an opportunity to, if it's a cooling dominant building and we're more efficient, architect or engineers may actually be able to slightly undersize the heat pump, but in most cases the size stays the same as a conventional building.
I guess maybe I'm just gonna, okay, on gallery. So a question from Mark: how does your flat rate for heating and cooling compare to existing gas and hydro bills?
Yeah, so I think it's important to recognize the energy savings is one aspect of geothermal. Probably about 60% of the benefit of geothermal is electricity and gas savings. The other 40, mentioned is maintenance and repairs, chemical contracts. There's some insurance savings. There's the capital reserve no longer to replace all of those things. So when you add up the operational savings, which goes far beyond just energy, and you compare that to a geothermal utility charge, I'd say plus or minus within 5%, it's about a wash. But that also we have to recognize that nobody paid anything, right? So if you're moving into a geothermal building, it's not like you paid a premium for your condo, and the builder didn't pay a premium. So to get a low carbon building for the same price that is quieter, looks a little bit better, and future-proofed, it's almost like a free insurance policy. And I think that's where the win is for the condo corp. It's not about necessarily day one energy savings. It's about a future-proof building that's costing you no more to purchase, and your condo fees are exactly the same, all things being equal.
Great, thank you. A question from Brian McLean: is geothermal potentially feasible and economical for a neighborhood of single-family housing?
Yeah, absolutely. That's not our business model, but there's a big difference between our business model and the feasibility of geothermal. And we're seeing that in neighborhoods across North America where And there's different ways of doing this. Sometimes it's what they call sort of thermal highways, where it's a combination of geothermal and other technologies, and you tie all the homes together. Or you can just have a neighborhood that gets together, because there are some economies of scale. Mobilizing a drill rig is pretty expensive. It's definitely more economical if you could do 5, 6, 7 houses at the same time. So if a neighborhood could get together, there'd be some cost savings there. But in most cases, as long as there's enough room for a drill rig to park and drill the hole, that would be the only caveat. You'd only probably need 1 hole per home in the front yard, and you could retrofit existing homes.
So have there been, just a follow-up to that, have there been any projects like that have gone to a utility model? Because I've heard of a story where that didn't work because of cost.
Yeah, I think that's why we haven't really looked at single family homes for our utility model. The economics aren't quite there. So the technical feasibility of residential homes in the city is there. Is it financially feasible? I'm not really sure, to be honest.
Okay, so a question from Karen Merkler. Who owns the system in a condominium? Is it turned over to the condominium corporation, or is it a lease and/or maintenance agreement with Diverso?
So during that 30-year term, we own the asset. It's technically ours. We don't own any lands. We don't own a unit. So we try to keep this as legally simple as possible. But for all intents and purposes, we own the asset. The condominium corp has the option. If they want, they can buy it back from us at a very reasonable amount. But yeah, we own the asset, which also means which is why we take on the operational responsibility and the performance responsibility of the system as well, just like any other utility.
Great. So a question from Don regarding the Toronto Green Standard. Don says, it's my understanding that the Toronto Green Standard requires that you rough in connections to a district energy network. Have you used this? Have you used this connection? That is, have you done any district energy? And what about thoughts to expanding service to adjacent buildings and neighborhoods?
Yeah. What time is it? 8:20. I think David McMillan's on the line. He's probably laughing right now because he knows what I want to say about that. But I think, yeah, district energy is a complex conversation, and there's a time and place for anything. And I think, one of the advantages of district energy is when you have multiple buildings with very diverse energy loads. So you have a library and a manufacturing plant and an office building and some multi-residential and a skating rink. You have this diversity. When you tie it all together, there's this efficiency you get through that. Our perspective on it, and we're doing lots of master plans with 6, 7, 8 buildings, is it's simpler, because the problem is, if you have 8 buildings going up, if you install a lot of infrastructure up front, there's this thing called time value of money, right? You're installing money up front, you're deploying capital, but the project's phased out over 10 years. So that in itself is a problem. But then what about if 10 years turns into 13 years and 10 buildings turns into 7 buildings? That becomes very complicated. So our approach is just put an individual geothermal system underneath each building, because if all the buildings have the same energy profile and they're all multi-residential, you don't really gain much, believe it or not. And this is kind of the misconception of district, is that there's economies of scale, and there isn't always economies of scale. You have legal complexity, additional costs of tying it all together. So our approach has been keep it as low carbon as possible by putting a geothermal under each one, not requiring any natural gas, have individual contracts, individual systems, and then capital deployment is aligned with the phasing of the project. So you're never deploying capital ahead of schedule and taking on that financial risk. So that's a whole other, I could do a whole other seminar on that. So
it's a complex subject, that's for sure. That's part of what we're trying to untangle.
So I will say, to give a shout out to where district makes a lot of sense to me is on existing buildings where you can't drill from underneath. And I thought David McMillan might chime in, because I've never heard of district energy rough-in being part of the Toronto Green Standard. So I think Toronto, as I said earlier, the Toronto Green Standards is an incredibly fair policy because it doesn't dictate what a developer does. It only dictates the end result through the lens of carbon and energy. So.
Right. So we have a question from Kyle, Kyle Duncan. You mentioned that developers are competitive, and now if one developer is doing geothermal, others are being influenced to follow along. However, it doesn't seem like they put up front geothermal is silent. How about something on a building that flags it as geothermal, like a flag?
Not sure I fully understand the question. Developers, yeah, they are competitive, but having another developer do something innovative, it's not necessarily going to persuade a developer to do it, but it's going to make them intrigued, and it's going to make them look, and it's going to make them question, which is kind of where it's provided opportunity for us, providing we have a good solution and they, see it as viable and they trust us as a provider that can do it without impacting their project, then they'll move forward. So I think there's influence as a result of multiple developers doing it, especially larger developers. And I'd say more particular or more specific, developers that aren't necessarily known as being low carbon and progressive. And when developers see those developers doing it, that's what kind of makes them look twice. Oh, well, if they're doing it, maybe there is something to this and I should take a look at it.
Right. And you talked about them being conservative. So this is de-risking when they see that.
I wouldn't say de-risking. I would say it adds risk. There's no doubt that geothermal adds risk, but they're looking at it as the benefits outweigh the risks because they know they have to future-proof. They know this is coming. They'd rather do it under their terms than wait till they have a gun to their head and they don't have a choice. But if they could, they would not do geothermal. That would be their first preference for sure.
Question from Susan Mayrand. Are there any grants to help the financial impact when retrofitting an existing building?
I don't know about grants, and we don't get involved in a lot of retrofitting, but I do know the city of Toronto has a very aggressive green loan program to help, whether it's condominiums or building owners, retrofit existing buildings. And that's not just geothermal. I think it could be a boiler upgrade or new windows or anything to do with energy conservation. There is substantial capital available from the city of Toronto to help with that.
I know you mentioned it before that Karen Mergler has a question about maintenance. What is the typical maintenance required on a geothermal system?
Yeah, so for the building owner, in our case, 0, because we own it. But for us, it's not so much about maintenance, it's more about energy or about monitoring. So almost every one of our systems, and no disrespect to property managers, but buildings never operate the way they were designed or the way they were commissioned. They deviate. A set point gets changed, somebody changes something, and it changes the energy profile. That's what impacts the geothermal. It's kind of like, your body was built a certain way. If you all of a sudden shifted and started smoking or started eating McDonald's every day, it doesn't have an immediate impact, but over time, it starts to create problems. And over a long period of time, it can create a major problem. And that's kind of how geothermal works. Those little incremental changes change the energy profile, more heat going in than what's coming out. Not an issue in year 1, 3, 4, 5, 6 years down the road, that temperature gets warmer every year, and all of a sudden it's at a point where it doesn't work anymore. So that's our responsibilities. Every 3 months, we do a little kind of a checkup, I guess, on each of our systems. We look at the trending, we do a report, and then we'll report back to the property manager if there's an issue and say, hey, can you please adjust that down or turn that up, or let's try making this change, and then we'll check it again in 3 months. That's sort of the maintenance that's required at geothermal. It's not your traditional change filters and belts and that kind of thing maintenance. It's not a physical maintenance. It's an operational maintenance.
So there's another question from T. Anderson. Given that the Toronto Green Standard Tier 2 is not mandatory until 2028, will the geothermal boom be delayed until then? Do you think there'll be another bump?
No, so I think to understand the Toronto Green Standards, there's different versions. And right now we're in version 4. So in version 4, and then each version, it happens every 3 years. So now we're in version 4. There's 4 tiers. Tier 1 is mandatory. and tier 2, 3, and 4 are elective. So right now in 2023, it started in 2022 basically with version 4. Tier 1 is very aggressive. Tier 1, we're finally at that tipping point now where the TGS is actually driving change, and it's actually forcing developers to look at alternatives. The next, and what they do is version 5, tier 1 is the equivalent of version 4, tier 2. So it's going to be stepped up. It's kind of like they're just turning the heat up every 3 years, and they're at the point now where they're making them uncomfortable. Version 5, it's not just geothermal. There's going to be other things that change as well, because now they've turned the heat up even more. So
Thanks. For David McMillan, David, do you want to unmute and explain yourself rather than me reading this?
Oh, sure. Yeah, happy to do that.
David's with the city.
Can you hear me okay?
Yeah.
Yeah, so there's just the point about requiring rough-in for district energy. We used to have a requirement for tier 2 projects, so voluntary, that you would rough in for district energy, but for some of the reasons Tim mentioned, it doesn't make a lot of sense. And so what we did instead is we developed guidelines, costed out guidelines that basically they're meant to be for low temperature mechanical system design. So if a developer uses that, if they can't do a geothermal system or district energy connection today, their building is designed to enable that in the future. So essentially, we're agnostic on the technology, which is more in line with the Toronto Green Standard, and it allows developers to make the choice, or building owners in the future, of what technology makes the most sense at the time. And so we encourage real estate developers to speak to companies like Diverso and others if because we see the opportunity. But yeah, there's no mandate to rough in.
Okay. And you had something else on the financing. Do you want to just speak to that while you're unmuted?
Sure. There was a question about grants. We don't have any grants for existing buildings. The city just generally doesn't provide grants because they're costly. What we do have is recoverable debt programs, so we can issue low interest loans primarily to building owners, not so much to developers. It's a challenge for new construction, but for existing building owners, they can take advantage of sustainable energy plan financing. And for homeowners, we have the home energy loan program, which you may have heard of. At this point, it's a zero interest loan program because of some federal support, but the program is oversubscribed. So hopefully we'll be able to renew it and get that going again.
Thanks.
You're welcome.
So we have a couple more questions, and I think the last one I see there is Rita, and after that, maybe we'll talk about what's next. Hang on, David. Okay, a question from Kathy Nozadi. Following up on Kyle's question, is there a benefit to educating and informing the public about geothermal? Is there any way to tell by looking at a building if it's heated and cooled with geothermal instead of gas?
Kind of a two-parter. So to answer your first question, of course, there's a benefit to educating the public. From my experience, educating and creating change don't always go hand in hand. But I think what that might do, the more that people understand geothermal, the benefits of geothermal, and the desire to invest in a building with geothermal, that in itself will drive change, because now it's about purchase decisions, and developers make decisions based on purchase decisions. And everything I've heard for the last 10 years is, I don't need to put in geothermal because my condos sell out in 2 weeks and nobody could care less whether it's a green building or not. So if that changes, then the developers will change. Until that changes, they won't change. And I forget the second half of that question.
Is there any way to tell, I guess, if you're on the roof?
Yeah, I guess sort of. If you look at a building with geothermal, what you won't see on the roof is a cooling tower or those big louvers where there's a cooling tower inside of the penthouse. And you'll also notice the mechanical penthouse will be smaller. And instead of being 6 meters high, it'll be 3 meters high. And that's, again, shout out to the city of Toronto. One of the ways of incentivizing developers to look at technologies like geothermal, they're allowing them to, if they can shrink the size of their penthouse, they're allowing them to reallocate that to saleable GFA. And in time right now where developers are having a hard time making the economics work, getting additional saleable density is a huge financial incentive for them. And it doesn't change the height of the building. It's just instead of a cooling tower, you're looking at a window. I would argue it looks better. So it's kind of a, in that case, it's a win-win for everyone.
Cool.
And what about the basement? Do you get less mechanical in the basement? Like, do
No,
you get more like parking space?
No, if anything, you might lose a parking space. That one
Okay.
image I showed of that manifold and those pumps, that's an addition to the mechanical
Okay.
system. So you gain up high, you lose a little bit of space down low.
I just want to thank you. I just wanted to interject for 1 minute. We've gone a minute over time. Tim, are you all right if we continue for, say, another 10 minutes?
Yeah, fine.
Okay. Thank
I
you.
think we also started a little bit over. So
Fair enough.
yeah,
Thanks, Rose.
thank you. Great. There's just a couple more questions. A question from Lee Adamson. If buildings side by side use geothermal, would the efficiency of geothermal under one building influence the next one? Is
Yes.
there a limit? Is there a limit to the number of buildings in a given area that can be geothermal?
Yeah, that's a great question. And we get that a lot. I mean, the simple answer is no. And the reason for that is going back to the misconceptions of geothermal. It's always kind of thought that we're pulling energy from the ground and we're rejecting energy into the ground and dispersing it out. With high density geothermal, with all of our boreholes 15 feet apart, kind of like a cluster, what we're actually doing is all of that energy is really contained underneath the building footprint. It doesn't really disperse out into the ground. So you can have multiple buildings like that exchange district. There's going to be 3 buildings, they're all side by side, and there's other master plans we're looking at with multiple buildings side by side, and there's really no impact because they're all running and heating at the same time. It's seasonal, and they're all kind of running and cooling at the same time, and we're only relying on kind of like a big cylinder or big energy source straight down 600, 700, 800 feet below the building, and that energy is essentially contained within that space.
So does the water
no
flowing, the water doesn't impact it, the water underground?
No. Our system is a closed loop, so it's a pipe, 2 pipes inside a hole connected on the bottom, so the water goes down and back up again. There's flowing aquifers. They may help benefit the system a little bit, but when you're going down 600 to 800 feet, the aquifers are quite small, so they're really only impacting a very small percentage of that overall borehole. So again, another misconception that flowing aquifers benefits the geothermal, and it's a pretty minimal impact, to be honest.
Don is wondering, what about interest rates? What is the impact when planning for 30 years?
Mm-hmm. Yeah, so right now, not to get too deep into our business model, we're Diverso. We were purchased back in April, so the ink is still drying on that deal. And what that's allowed us to do is a couple of things. One, grow, 2 buy drill rigs, but the fund who purchased us, they're a large fund out of Europe, and right now everything's equity, so they don't really care. It doesn't really make a difference what the interest rates are. Someday, if they want to, apply some debt or pull out a debt facility, then interest rates will matter. Hence why they're not doing that right now. But everything we do is 100% equity, so it has no impact on our charge or the financial viability of this.
And a question from Rita Bijan. Are buildings that are under the provincial aegis, e.g. long-term care facilities, subject to the Toronto Green Standard?
That's a good question for David. I am not sure, to be honest.
I can. Technically, no. But of course, we try to have a collegial relationship with our colleagues there, and we generally they are following the TGS. There may have some unique elements that make it difficult for them to follow it to the letter. Not so much on long-term care, but more on things like, Metrolinx properties. But yeah, generally they do, even though technically they are not subject to it.
So I'm just going to open it up. If anyone, I went through the questions kind of quickly. If there were any follow-up questions that we kind of missed, maybe raise your hands, or either wave or raise your hands if there's any clarifying questions or anything like that. I think we're at the end of our questions, and you've covered all of the questions, covered mine. So I think that was really informative and helpful. Sean, I see a wave there. Would you like to unmute? Oh, okay. Is that you outside of Toronto? Is that, or is
Oh,
that something?
Sean, if
Go ahead.
like
Yeah,
the
no, I
event,
just
go ahead.
forgot my camera was on and was actually literally celebrating how cool this was.
That's
It was really
Okay.
insightful. Great. Thank you so much.
Great.
I'm gonna head out. Bye.
Awesome. Thank you. No worries. So there is one more question. Outside of Toronto, what is the biggest market for geothermal?
So I'm assuming you mean outside of the GTA, because I would say our projects
Yeah.
are spread pretty equally across the GTA. Vancouver has a decent geothermal market, but to be honest, outside of that, Ottawa, now we're starting to see a lot of opportunity in Ottawa. More projects are looking at geothermal in Ottawa. Besides that, to be honest, there's really has not been the same level of penetration anywhere in Canada than there is in Toronto. And I think that's a combination of there's a couple of us that have been pushing this rope or pushing this rock up the hill for a long time, combined with the Toronto Green Standards, has kind of created this perfect storm of opportunity that just doesn't exist in any other municipalities.
So I'm going to turn it over to you, Kathy, just to close us out.
Sure. Okay. So first, Tim, thank you so much. That was a wonderful presentation, and we all really, really appreciate the answers to the questions. You've given us a lot. I think we've learned a lot, and you've given us a lot to think about. David, thank you also for jumping in. That's much appreciated. So now I think I will turn off the recording. Okay, let's see.